Hey guys, sorry I had to jump off right quick. Someone was coming to help with my computer and my TV, and so I needed to jump off so that they would not leave, even though it's still not working. Okay, so I was about to graph this coordinate point, negative 1, 120 degrees. So 120 degrees with a radius of negative 1 would pop it to the other side. And so you can see how by continuing the rotation, even though I need the points on here, that will do it because all my radii will be negative because all the cosines are negative. So if I say 135 degrees, cosine of 135 degrees is negative square root of 2 over 2 times 2 would be negative square root of 2. So if I were to graph that coordinate point, that was the 1.414, so negative 1.414 at 135 degrees. So 135 degree rotation, and then pop back over and do a negative 1.414. So somewhere in here. Okay, and then 150 degrees. The cosine is negative square root of 3 over 2, so that would be a negative square root of 3. So negative square root of 3, and then 150 degrees. So rotate 150 degrees and then pop back over negative square root of 3, which is negative 1.732. So somewhere in here. And then if I go all the way to 180, then I get, let's see, cosine of 180 degrees is negative 1 times 2 is negative 2. So negative 2, 180 degrees. So rotate 180 degrees and then go out a radius of 2 and then pop it back over. So it ends up back here. So by going through these, we can see that we've already created the circle by only rotating 180 degrees. Now, what if I kept going? 210. So if I kept going 210, the cosine of that would be negative square root of 3 over 2. Negative 1/2 would be the sign. But cosine of 210 would be negative square root of 3 over 2 times 2 would be negative square root of 3. So it'd be negative square root of 3, 210 degrees. So at 210 degrees, go negative 1.732. So 210, pop back over and go negative, or go 1.7, so that would put me back here. So every point is just going to keep repeating. Okay? So this is another way of writing r equals 2 cosine is another way of saying this circle form right there. Okay, let's talk about this one. Oh, well, okay, before I do that, I do want to say there's a shortcut if you think to do it. So x minus 1 quantity squared plus y squared equals 1. You could expand first, and whenever it's an x's and y, so x squared minus 2x plus 1 plus y squared equals 1. The 1 simplify each other out. And then you got x squared plus y squared minus 2x equals 0. Well, x squared plus y squared equals r squared. So we could have just said minus, and then x equals r cosine. So 2r cosine theta. And so we're right here much faster than it took to get there down here. Okay? So given a problem like this, if you're going from rectangular to polar, if you think to use the shortcut, or if you think to expand beforehand and then use that shortcut right there, then that'll make your life a little bit better. Okay. All right. So on this one, given what we just talked about, there are two different ways to do this. One is to replace x with r cosine. One is to replace y with r sine. Square both, and then go from there, right? But it's easier if you just go ahead and use this. X squared plus y squared equals r squared. So all of this might as well just be r squared equals 16, which means r equals, now technically you could say plus or minus 4, but by saying just r equals 4, you're perfectly fine, because that means no matter what angle you're at, the radius is 4. So no matter what angle, you're at a positive radius of 4. And if you say negative 4, well, it pops it over here, right? But you're still on this ring right here. So the equation r equals 4 is a very simple way of saying a circle centered at 0, 0 with a radius of 4, which is what this tells me. A circle centered at 0, 0 with a radius of 4. So r equals 4 is kind of a nice way to just write that circle equation with no shifts. Okay. Let's talk about this one, or these two. So this is a vertical line, x equals 4, so what we're going to do is we're going to kind of play around with that. I need it in terms of r's and thetas, so I've got x equals r cosine, so I'm going to say r cosine theta equals 4. So if I want to solve for r, then I would say r equals 4 divided by cosine of theta, or r equals 4 secant theta. Cool? It's easier for me to think it in terms of cosine as far as like graphing, so that's what I'm going to use right quick to show you that we're going to get just a vertical line x equals 4. Okay, so here we go. We're going to do a series of points just like I done the last one. So here we go. At 0 degrees, so we're going to go with the theta and what is the r, right? R equals 4 secant theta. Okay, so if theta equals 0 degrees, cosine of 0 degrees is 1, so 4 divided by 1 is 4. So we've got the coordinate point 1, 0 degrees. So rotate 0 degrees and, sorry, 4. And okay, so at 0 degrees we go out a radius of 4 units. Okay, let's try 30 degrees. Okay, cosine of 30 degrees is square root of 3 over 2. So 4 divided by square root of 3 over 2, well, when you divide by a fraction, you flip and multiply, right? So we're going to multiply by 2 over the square root of 3. So it becomes 8 over the square root of 3. And 8 divided by the square root of 3 is 4.619 or 4.62, 4.6. So 4.6-ish, we'll call it that, 30 degrees. So we're going to rotate 30 degrees and go out 4.6. So rotate 40 degrees, go out 4.5, 4.6. So somewhere in there. Okay. Now we're going to go 45 degrees. So 45 degrees, cosine of 45 degrees is square root of 2 over 2. 4 divided by square root of 2 over 2 is the same thing as 4 times 2 over the square root of 2. True, multiply by the reciprocal. So I get 8 divided by the square root of 2. 8 divided by the square root of 2 is 5.7-ish, right? Okay, so we're going to go 5.7, 45 degrees. So if I go 45 degrees, and then I go out a radius of 5.7, so 5, 5.5, 5.7, somewhere in there, you can see how it's creating this vertical line. Now, I don't even know if I'm going to be able to see this one, but maybe. Let's try one more, 60. So 60 degrees is, cosine of 60 degrees is 1/2. So that would be 4 divided by 1/2, same thing as 4 times 2. That would be 8. So that would be the coordinate point 8, 60 degrees. And yeah, 8's right there. So at 60 degrees, it would be at a radius of 8. And you can see how it, in fact, does create this vertical line. Now the interesting thing is what happens once we get, so far it's just connected these, right? What happens when we go to 90? So when we go to 90, cosine of 90 is 0. That's undefined. Okay, so let's pop over to 120. If you do 120, cosine of 120 is negative 1/2, right? So that would be 4 divided by negative 1/2. That's 4 times negative 2. That would be negative 8. So at 120 degrees, negative 8 would put me right here. And so I have a feeling that it would then come up and meet that, which is kind of interesting. But anyway, you end up with that vertical line, x equals 4. Okay? And that was just us exploring that they are the same thing, x equals 4 versus r equals 4 secant. Yeah? And same thing here, y equals 3, r sine theta equals 3, r equals 3 divided by sine theta, or r equals 3 cosecant theta. So in the same way that this created that vertical line, this one would create a horizontal line at 3. So at this angle it would be here, and at this angle it would be there, and at this angle it would be there, and at this angle it would be there, and at this angle it would be, well, I don't have that one drawn. But let's check like a couple. So I'm thinking that at 30 degrees it should be close to 6, right? Or even 6. If I plug in 30 degrees, sine of 30 degrees is 1/2, and 3 divided by 1/2 is 3 times 2, so that is 6. So that would be there. And let's go 45 degrees. Sine of 45 degrees is square root of 2 over 2. 3 divided by square root of 2 over 2 is the same thing as 3 times 2 divided by the square root of 2. And 6 divided by the square root of 2 is 4.24. So it would be 4.24 at 45 degrees, 4.4 and a quarter, so somewhere right in there. And there we go. Yeah, that makes sense. Okay, I'm going to create that horizontal line. All right, now let's go from polar to rectangular. I've got an equation r equals 8. Now we should know that r is just the radius. So if they're telling me, hey, radius is 8, then that literally means I have a circle centered at 0, 0 with a radius of 8. Okay? And I know the equation of a circle centered at 0, 0. It's x squared plus y squared equals r squared. Well, if r equals 8, then that means r squared equals 64. True? R squared is x squared plus y squared. I'm trying to go from r's and thetas to x's and y's, and so I can just make that right there, that substitution. X squared plus y squared equals 64. And that is the rectangular form of the same equation. And then we talk about this one. So this one's kind of interesting. It says theta equals pi over 6. So if I asked you to graph the function theta equals pi over 6, then what you're dealing with is for all radiuses, the angle is pi over 6. So radius 1, pi over 6. Radius 2, pi over 6. Radius 3, pi over 6. Radius 4, pi over 6. They're all pi over 6. And in fact, the radius negative 1, pi over 6. Negative 2, negative 3, they're all pi over 6. Which means we've got a line, right? We've got a line straight through the center with some kind of slope. And in fact, we should know what that slope is, right? If I were to graph the 30, 60, 90, with this being 1 unit, right? I know the short leg is 1/2 that, and the long leg is square root of 3 times the short leg. So if I thought about, like, what's my slope for this line, right? What's the slope for this line? It's rise over run. I rise 1/2, I run square root of 3 over 2, I flip and multiply, and I guess I could have done that. And I get 1 over the square root of 3. Yeah? Or square root of 3 over 3. That's going to be the equation of this line. Y equals square root of 3 over 3x, or y equals 1 over the square root of 3x. And let's prove it. Okay. If theta equals pi over 6, I need to go from thetas to x's and y's. So I see this relationship right here has both theta, x, and y. But it has tan inverse, so if I think about it, I know that this also means that tangent of theta equals y over x. So if I had a tangent here, then I could replace it with y over x. So I'm going to go ahead and throw a tangent in front of both sides of the equation. Tangent of theta equals, well, what is tangent of pi over 6? Tangent is sine over cosine, the y over x, so y divided by x, 1/2 divided by the square root of 3 over 2. So 1/2 divided by the square root of 3 over 2. We just did that, and that is 1 divided by the square root of 3, or square root of 3 over 3. Cool. Okay, still not in terms of x's and y's, but I do know that tangent of theta equals y over x. Yeah? So y over x equals square root of 3 over 3, which means y equals square root of 3 over 3x. And there's your equation that matches that function. Okay. Let's do 2 more. And they're very straightforward. Well, one of them is anyway. Okay, this one right here. We already have seen a graph or seen a function like this when we went from rectangular to polar. So using that, we know, well, I'm just going to rewrite secant as dividing by cosine, and then I'm going to multiply by cosine on both sides. And the only reason I'm saying this quickly is because we just did a problem going the opposite direction, so it's just undoing the same processes. So I've got r cosine theta equals 5, and r cosine theta is x. And so there we go. So if you end up with r equals some constant times a secant or a cosecant, then you can just undo this, and it's either an x or a y equation. But then we've got this last one, okay? So this one's a little bit interesting because it's not secant or cosecant, it's cosine. So, um, okay, we've got a couple options as far as how to attack this. What I know is that I have r's and thetas, and I want x's and y's, or just x's or just y's, but I just need x's and y's in general. So, okay, a couple different ways I can see um, you attacking this. One is to piece it together. So, I could see a student saying, well, cosine of theta equals x divided by r. Okay. And so if I had r equals negative 8, um, cosine theta equals x divided by r, then that would be times x divided by r. True? Or negative 8x over r. Okay, well then, if I'm trying to solve for x, I don't like the r in the denominator. I'm trying to get the r's together because I do want to get rid of them. I can multiply both sides by r. So if I multiply both sides by r, then I get r squared equals negative 8x, and I know that r squared is x squared plus y squared, which we are completely not done. But that is one way to kind of piece it together. The other option is you recognize, well, I have an r, I need an r squared. I have a cosine, I need an r cosine. What if I just multiply both sides of the equation by r? Then I've got r squared equals negative 8r cosine theta. This right here is x squared plus y squared. And r cosine theta is x, so that's minus 8x. Now what we're going to do is we're going to rewrite this in terms of a circle, because our very first one where we had a circle not centered at 0, 0, let's see if I can find that page. I think it was this one. Yeah. Remember how this turned into r equals 2 cosine? So we're dealing with a very similar situation. We're going to end up with a circle not centered at 0, 0, which is why it's a little bit more involved. Okay, so x squared, we're going to add the 8x over, plus, and then plus y squared equals 0, plus. What we're going to do is we're going to complete the square with the x terms, because it has the linear term it needs to complete the square. This one does not, which means it has no vertical shift on the center of the circle. Okay, so just a reminder, completing the square, like x plus 3 quantity squared is x squared plus 6x plus 9. So if you cut the middle term in half, you get the what this is, and if you square that, you get that, right? So if we cut the middle term in half, 8, we get positive 4 squared. 4 squared is 16. This right here is this right here, but the only way I can add 16 to one side is if I add 16 to both sides. So x plus 4 quantity squared plus y squared equals 16, and that is an acceptable form because it's the standard form of a circle. Okay, a circle centered at negative 4, 0 with a radius of 4. And that is that.